Hey guys, welcome to Environmental Engineering 280. This is lecture 24. It's basically a wastewater treatment 1, and today we'll be going over 2 example problems. So let's begin. Okay, so for our first problem, we're given that a rectangular primary clarifier, which is 2.4 meters deep and 4 meters wide. It's designed to settle a flow of 2,000 cubic meters per day and have an overflow rate of 32 cubic meters per meter squared day. And we're asked to find, what the length of the clarifier should be and what the detention time should be. And this automatically tells me some equations to use. Some equations to memorize, I should memorize these for the exam, is these two. Okay? So we have um, the overflow, the overflow rate, is equal to the flow rate divided by the area. Okay? Now, we can really see that this overflow rate is it's in a unit of velocity, right? Because the rate at which it's overflowing. So we should get something like meters per second. And you can really figure out if your equation's right or not by seeing, if your units cancel out to meet what you want right here. So if we have a flow rate that's usually given, if we're doing this in meters, it's like cubic meters per second to keep it simple. And we would divide by an area, which is any, foot meters squared. We would just get a unit left, which is in meters per second. So we know that this equation checks out. Okay, and the next equation is the detention time, right? And this should just be in units of time, seconds, hours, minutes, right? And well, that's just equal to volume divided by um, the flow rate. All right, so we have volume, which is cubic meters. I'm doing my check rate here, right? And our flow rate, it's meters, cubic meters per second. Well, these meters cubes just cancel, and we're just left with seconds. That's in fact a unit of time. So our equations are good to go, right? Without even, you can memorize these equations by brute force, but you can really just think them through as well. So to the problem itself, let's go ahead and begin with number 1. We have to find the length. So, which of these equations will give us length? Well, what makes area? It's length times width. That would give us area. So, we're given the overflow rate, which is 32 right here. So we can go ahead and plug it in. So 32 cubic meters per meter squared day. That's just equal to the flow rate, which is given to us right here, which is 2,000 meters cubed per day, divided by the area, which is length, what we're trying to find, and the width was given to us, which is 4 meters. So if we just solve for L, let's check if our units cancel. I already see meters cubed canceling out, day and day, meters, and we're just left with 1 meter, right? Which is perfect. So 2,000 divided by 4 divided by 32 is in fact equal to 15.63 meters. And that is given to us right here. So we know that's correct. So problem 2, or part B of problem 1, we're just trying to find the detention time. Well, the equation's right here. We just need to find the volume. So, we just found the length. And we know that volume is equal to length times width times height. But in this case, it's depth, it's deep. It's all the same. So we can use our length, which is 15.63 meters, times that by width, which is 4 meters, which is given up there. And our height, which is our depth, which is just 2.4 meters. And this equals to 2.4 times it by 4 times it by this. 150 even cubic meters, right? So now that's not our answer. We can use this, plug it to this equation over here. So our detention time is actually equal to 150. I don't know why I put that up there, but cubic meters divided by the flow rate, which again is given to us as 2,000 cubic meters per day. Meters cubes cancel, we're left with days, so we get 0.075 days. So the answer is given to us in hours, so let's go ahead and just convert this to hours as well. So we got 1 day is equal to 24 hours. Days cancel. Multiply that by 24, and we do in fact get exactly 1.8 hours. Alright, so that's it for question 1. Let's go on to question 2. So question 2 gives us that a final settling tank for 2 million gallons per day of activated sludge. Now keep in mind MGD is million gallons per day, right? So that's flow rate, because what else? I mean, it's not an overflow rate. It's oh no, it is the overflow rate. So anyways, I'm sorry guys, I lost my train of thought here, but anyways, a final settling tank of 2 million gallons per day activated sludge treatment plant has an average overflow rate of 800 grams gallons, not grams, gallons per day squared feet, and it needs to have a minimum detention time of 2 hours and to allow proper settling, and it must be 11 feet deep. So given us, if we're trying to find the diameter, this automatically tells us we have to use the area equation, because area we know is of a circle is pi r squared, and the diameter is equal to 2r, right? So let's go ahead and write out our equation again. It's the flow rate is equal to, you guys catch my mistake? It's the overflow rate. It's equal to the flow rate divided by area. So we're given the overflow rate as 800 gallons per day foot squared, and we have 2 million gallons per day divided by the area, right? So which is just pi r squared. So we can see that the gallons cancel and the days cancel. So that's perfect because our area should be, in fact, foot squared. Now we just got to solve for r, so we can rewrite this as r squared is equal to 2 million divided by 800, and we also have to divide by pi. So we solve for r, type this all in the calculator, we shall get r is equal to 28.21 feet, right? So now we just have to multiply that by 2 to get it in diameters, right? Because that's what they're asking it for. So that'll give us 56.42 feet, just as the answer says is above. And yeah, that's it guys. Hopefully you guys got some help out of this, and I'll see you guys in the next one.